Good morning, students. So now we are going to plot a relation between radius of curvature and focal length. So students, this is going to be a generalized topic. We are not going to study it for convex mirror or concave mirror. Actually, we are going to study it for both. So in short, we can say we are going to study this relation for a spherical mirror. So one by one I will plot the both and I will just make you familiar with this condition. So let us take first a concave mirror. So one concave mirror I have considered, and this is of a small aperture, and suppose this is the point and this is going to be the focal point and center of curvature. Here somewhere will be its center of curvature. Very good. Suppose a ray of light AB is approaching towards this mirror. So let me show this. A ray of light AB is approaching towards the mirror, and this is parallel to this. This point is going to be P. This is the pole. Now this is approaching parallel to the principal axis, parallel to CP. Very fine. Now once it will incident here, this have to pass through a point, and that is focal point. So after reflection, this ray of light is going to reflect in this direction from the focal point. If I have to apply the law of reflection, then at the point of incidence I have to plot the normal, and as you know, the normal at this point will pass through the center of curvature. The normal at any point will pass through the center of curvature. So center of curvature I already have. Let me draw the normal at this point. This dotted line is actually showing the normal. Now where will be the angle of incidence? You all know that this is the incident ray and this is the normal. The angle between the incident ray and the normal, that is angle of incidence. So here angle of incidence. And angle of reflection will be the normal is here, and this is the reflected ray, so this is going to be the angle of reflection. Let us consider this angle L. So this figure is very clear, and that is for concave. Now students, let us plot the case for convex mirror. So here I have considered a convex mirror, and suppose here is I have shown in the backward direction as well. When a ray of light will approach here, ray of light AB will approach here. So as you all know, this will go in backward direction, but we have to assume the focal point. So suppose there is the focal point and here is the center of curvature. So in backward direction, if I will show, this is how a ray of light is assumed to go, but in actual practice, this is going in this direction, backward direction. Just extend this BF in backward direction. Fine. Now plot the normal. So normal will pass through the center of curvature from the point of incidence. So this is going to be the dotted line is the normal. Just extend this in backward direction. Now apply the law of reflection here, and let us consider this angle alpha as well. Now where is the angle of incidence? Ray of light approaching. Okay, incident ray. This is the normal. So this is going to be the angle of incidence. Now where is the angle of reflection? This is the reflected ray. This is the normal. So this angle is going to be angle of reflection. If this angle is R, by vertically opposite angle, this angle will be also R. Now this figure is for convex mirror. Now whatever we have done, let us write it in the form of language. So consider a ray of light AB. Consider a ray AB parallel to This is parallel to principal axis or parallel to CP, and after reflection passing from the focal point. So the general language we can write passing from the focal point. Very fine. Now students, if we will apply the law of reflection. So according to law of reflection, according to law of reflection, what is the condition according to law of reflection? Angle of incidence is equal to angle of reflection. This is the condition. Now let us check this condition in triangle BFC. In triangle BFC, suppose we check this condition, then we already know angle of incidence is equal to angle of reflection. Very fine. And here, which two angles are here? Angle of incidence is equal to angle of reflection. So, but if you will check, angle of incidence is already equal to angle alpha. Why? Angle of incidence is y equal to angle alpha, as AB is parallel to CP. So, in the case of concave mirror, this alpha is equal to I, as these two are alternate interior angle. In the case of convex mirror, this angle I is equal to alpha, as these two are corresponding angles. So, these two angles are equal. Angle I is equal to angle alpha. But if you will combine these two equations, equation 1 and equation 2, I is equal to R, I is equal to alpha. So by these two, from equation 1, 2, angle I is equal to means angle R is equal to angle alpha. Now in this triangle, if you will use in triangle BCF or BFC, if two angles are equal, then side opposite to these angles are also going to be equal. So just opposite to alpha, just BF, and just opposite to R, just CF. So BF will be equal to C. Now either we write this BF is equal to C. Very good. So if we write BF or if we write FP, both are almost equal. BF is almost equal to FP. Why? Because already we have considered that the mirror which we are considering having a small aperture. So by this we can see FP is equal to C. Now if you will use the equation, what is the equation? That CF, what is this length? Focal length to pole. This is going to be the focal length. Focal point to the pole, focal length. And this is going to be from the center of curvature to the pole. This is going to be the radius of curvature. Similarly here, this is point pole. So this focal point to this focal length and center of curvature to pole, radius of curvature. Very good. Now according to this, CF plus FP is equal to how much? CP. But as we have proved that CF is equal to FP already, CF is equal to BF and BF is equal to FP. So CF plus FP is equal to CP. In place of CF, what we can write? Let us remain this CF as FP. So FP plus FP is equal to CP. FP plus FP, 2FP is equal to CP. Now let us substitute the value. 2FP means 2F. CP means R. So this is the relation. R is equal to 2. Radius of curvature in case of a spherical mirror is double of the focal length. Or what else we can write? Focal length is half of the radius in case of any mirror, any spherical mirror. Either that is convex mirror or concave mirror, this is going to be the relation. So I hope you understood it. Thank you. God bless you.